So we do need to talk about fractional exponents. It's called, if you look in your textbook or on the study guide I gave you, it says rational exponents. What you need to take from that is different ways of writing rational numbers. Okay? So you could maybe think of this as fractional exponents, exponents that are fractions or decimal. I don't know if you thought about what the next logical step is, but in grade 7 or 8 you learned about just whole number exponents, right? 2 to the 3, 2 to the 5. What does that mean? That was grade 7 or 8. And maybe into grade 9 a little bit. Grade 9 you started to learn some exponent rules, but this year in grade 10 we're going to extend that. We've already extended it to exponent or to negative exponents. Right, so if you think about the patterns that we've looked at for negatives, right, just use the power of 2 here. This was 8. This was, actually let's use 3 as the base. I think it makes a little more sense. 3 to the 3 was 27. 3 to the 2 was 9. 3 to the 1 was 3. 3 to the 0 was 1. And then this year we extended it. 3 to the negative 1. If you keep following that pattern, you got 1/3. 3 to the negative 2, 1/9, right? 1 over 3 squared. Now we have to look at the numbers in between these here, right? In between 0 and 1, in between 1 and 2, fractional exponents. So things like, what does this equal? 3 to the 1/2, or 9 to the 1/2, or anything, right? 27 to the 1/3, 16 to the 1/4. Okay, that's what we're looking at now. What does that mean? Now in the next 2 sections, in the next little while, we're going to work on it. But just as a starting point, you're going to start to experiment with what do fractional exponents mean, or decimal exponents. You can experiment. For this section, I'm sort of assuming you have a calculator and you're working with it on a calculator. Right? So if you want to know what a number to the 1/2 is, like it might not mean anything to you here, 3 to the power of 1/2. If you just kind of randomly put numbers in and say like 7 to the power of 1/3, number one, you can put in 1/3 as just 1 divided by 3. If you're doing it on one of the calculators that I have to borrow here, these ones, you're going to have to put it in using some brackets here. Okay, this calculator shows it that way where you don't need to put brackets, but when you're starting to work with with fractional exponents here, like if you're doing 8 to the power of 1/2, you can't just go 8 to the power of 1 divided by 2, because it's going to do some order of operations here. It's going to do this exponent first. It's going to do 8 to the power of 1 and figure that out, and then it's going to divide it by 2. So that's not the right thing. It's not just half of the number. If you want to know 8 to the power of 1/2, what you have to do is 8 to the power of, with brackets, 1 divided by 2 on most calculators. If you have a calculator where it shows it as little numbers like this, you don't have to, but there you're going to have to do this. It's some weird number. If you want to figure out what it is, what you need to do is, I'm going to show you this for a second here right now, and we're going to look at some numbers and see if we can see a pattern here as to what they mean. We're going to do a set of numbers here, okay, and then we're going to do to the power of 1/2 here. So I'm going to put numbers in here like just 1, and then I'm going to do this one as 2, 3, 4, and then continue that pattern down. Okay, this pattern. If we continue this down, it's just going to be getting one bigger there every time. We can continue that down later. Here we're going to go equals this number to the power of, and a computer's that, power of 1 divided by 2. Okay, we're going to see what it gives us. And then if we follow this down, okay, we'll see what we get here. So each of these numbers is this number in this column to the power of 1/2, right? If you continue this down here, what do you think? Can you see any pattern? Do any of them jump out at you as making sense of what to the power of 1/2 means? Certain ones are whole numbers. Which ones are whole numbers? Which ones come up as whole numbers? Well, 4 to the power of 1/2 is 2. 9 to the power of 1/2 is 3, according to this software. 16 to the power of a half is 4. 25 to the power of a half is 5. What is raising something to the power of a half the same as? By the looks of it here. What is it? Square the opposite. Square rooting it, looking at the square root. It is the square root. If you predict it here, then this one should be a whole number here. This one's 7, right? The next whole number should be if we get to 64 here. Continue this down. Right? 64, 8. To the power of a half is the square root of a number. If I make a third column here that's raising it to the power of 1/3, so this one's going to be equals that original number to the power of 1/3. Okay, that one, any 1 to the power of anything is always 1. It doesn't matter what you do. I'm gonna follow this down here. Okay, we'll see if we can make some sense of this. If you go back up here, there's far fewer of them that are whole numbers. Where's the first one that's a whole number occur? 8, right? 8 to the power of 1/3 is 2. Next one is 27. 27 to the power of 1/3 is 3. The next one that's a whole number here is way down here. It's 64. 64 to the power of 1/3 is 4. To the power of 1/3 is actually the cube root of a number. To the power of 1/2 is the square root of a number. If we did to the power of 1/4, it would be the fourth root of a number. What number times itself 4 times gives you that? This number is the cube root of this. If you multiply this by itself 3 times, you get that number. You've talked about what cube roots are and square roots are. Anyways, lovely. Great. Thanks for that message. That's kind of an intro to a really brief kind of start to what fractional exponents are. You're going to have lots of things you need to do with them. At first, you're going to be working with them with a calculator, and then eventually we're going to start to work with some expressions without a calculator. Okay? That's thing number 1 here.